Hi everybody, my name is Aashitha and I'm from saitechinfo. Today we're going to talk about differential equations. I've divided differential equations into 5 subtopics. So first, basic concepts. We need to know that like linear equations, quadratic equations, we have such an equation. This is the general form like x dy by dx plus y is equal to 0. This is a form, and when we differentiate it, we keep getting like these. Like if you differentiate it once, you get dy by dx is equal to y prime, or you can call it as y1. Next, similarly, by differentiating it twice, the second order, you call it d2 by d square
squared
y
y
by
divided.
dx whole square is equal to y double prime or y2.
Right.
So this is like the orders. Second, order versus degree. So order is the number of times you have differentiated an equation. And like for example, d power
D
4
power
y
4.
by dx power 4 plus d square y by dx square is equal to 0. Here the highest order is 4 because it is the highest number of times an equation is differentiated. So it is 4 here. And for degree, it is the power of the highest order. And here I've created another equation, d power 4y by dx power 4 whole power 3 plus d power 3y by dx power 3 whole power 4. Here the degree is 4, see 3, because the highest order here is 4. So the degree of the highest order is 3 here. Next, solution types. There are two types of solutions, general solutions and particular solutions. So the general solutions are like dy by dx is equal to 4 minus 2x, and 4 minus 2x here is the arbitrary constant. This general equations only have arbitrary constant, while particular solutions do not have arbitrary constants. And suppose sometimes they ask you like how many arbitrary constants are in the general solution. They will give you an equation. For example, the highest order is 4. Then for the nth order, fourth order, the number of arbitrary constants are 4. And
So
if
it
it's
means
4,
if there are two arbitrary constants,
we'll have
the
to
second
differentiate it
order
twice.
twice.
And particular solutions, example, d square y by dx square plus y is equal to 0. Here as you can see there is no arbitrary constants. So obviously the number of arbitrary constants are 0. So if they ask you the number of arbitrary constant for a particular solution, it's 0. Next we are going to talk about family of curves in a general solution. Here mostly they'll ask you in two types, either an ellipse or circle. And we just use these formulas and we substitute the value to get the answers. Next, solution methods. There are three types of solution methods. First, variable separable differential equations. It is also known as heterogeneous as we can differentiate them both. Like in this, we can easily take out the y and put all the y components this side and all the x components that side. That's why it's like this, and it's called variable separable differential equations. Next, homogeneous differential equations are also known as variable inseparable differential equations. Example, dy by dx is equal to x plus y by x minus y. The formula is also the same as a variable separable, but the degree of the differential should be 0. And once we prove that this solution is an homogeneous equation, then we are going to use y is equal to vx, and then we differentiate in terms of v. After differentiating in terms of v, we get a big equation in v that we are going to use as v is equal to y by x. V is equal to y by x, and we substitute that in the last equation to get the final equation. Last, linear differential equations. This is the general formula, dy by dx plus py is equal to q. And here p and q both are different values which we will have to find out. In this equation example, I'll tell you.
What is that IF?
IF is the integrating factor. That is, here the integrating factor is e power integral of p dx. We are differentiating in terms of dx as there is we need an x term here. So after getting the value of integrating factor, we use it in this formula, this equation. That is y of integrating factor is equal
Put
to
y properly. This looks like G.
Y integrating factor is equal to integral of q into integrating factor differentiated with x plus the constant. Here the example is dy by dx minus y is equal to cos x. Here, as I've told, the form dy by dx is here. But here there is, in place of y, in place of p, there is minus y. See, minus 1. So value of p here is minus 1 and q is cos x.
That is the
So with
coefficient
that-
of Y.
So with that, we are substituting that this minus 1 here and differentiating it with x, and then we get that integrating factor, and that's how you solve to get to find a linear differential equation.
Oh, very
Thank
good.
you.